Welcome to another exciting educational video brought to you by Upvision Concepts Academy. So today's lesson, we'll be looking at chemistry and topic is water. Water. So water covers, this topic will cover the composition of water, the properties of water. You have hard water, you have soft water, purification methods, and water cycle. So we're going to also include like 10 past questions from NECO-WAEC in this video. So you can check the description of this video for more of those questions. So if you are new to our channel, kindly subscribe to the channel and get more STEM lessons. So water. What is water? You know, water is what we drink. We use it for many things, but we're looking at the chemical description, the chemical dissection of water. And actually it's a chemical compound. Don't be afraid of that word chemical. It's just that it has elements that forms it. So it's a chemical compound, and the molecular formula for that water is HO2, meaning that it comprises of hydrogen, 2 molecules of hydrogen, and 1 molecule of oxygen. So these are the 1 molecule, of course, molecule of oxygen. Okay, so and they are held together by covalent bond. On our description, held together by covalent bond. So if you are asked what kind of bond exists in the constituents of water, constituents, and I mean to say hydrogen and oxygen, it is covalent bond. Properties of this water. So even the water you drink, good water that is pure, properties, number 1 is colorless. Yes, that one, all of us know that one. So it doesn't have a color. So water is colorless, no color, no taste. How do you spell all this English word? Tasteless. No smell, odorless. Of course, I'm talking about pure water. Okay? Yes, so let me put that in pure form so that our viewers can understand. In pure form. So it does not have color, it doesn't have taste, it doesn't have odor. Secondly, it freezes at 0 degrees. Freezes at 0 degree. Okay? And boils at 100 degree. And boils at 100 degree Celsius. And there's a condition at 1 atmospheric pressure. Okay? So definitely this property will change if this atmospheric pressure is not this one. Thirdly is a universal solvent. A universal solvent. That means it can be used to dissolve anything. It can act as a solvent for anything. The universal solvent dissolves more substances than any other liquid. That's what I mean. So it dissolves more substances than any other liquid. Okay, it doesn't have any selection, it doesn't select what it dissolves. Okay, so other properties that I can say here is that the pH is neutral. pH is equals to 7, it's neutral. Let me just put that over there, neutral. Any other one I can remember? Density is okay, let me put density. Density is 1 gram per cm cube. This is 1.00, 1 gram per cm cube. That's the density of water. Okay, at 4 degrees Celsius, please. This is the condition at 4 degrees Celsius. So how do we test for water in the laboratory? So we use anhydrous copper 2 sulfate. So to test for water, so you will use anhydrous copper 2 sulfate. It turns from white to blue when water is present. So if you put anhydrous copper 2 sulfate and put water in it, the blue color we change to sorry, the white color we change to blue, show the water is present. Or if I have a cobalt 2 chloride paper, the blue color changes to pink in the presence of water. So let's note this laboratory test for water. So we're going to types of water. Types of water. So you have hard and soft water. So you have number 1, soft water, and number 2, hard water. We're not looking at the texture of the water. Literally, water cannot be hard or cannot be soft. That is just by looking at the feel. That's not what we are saying. We're not talking about hardness in terms of how it feels, not how it feels to the hand on the skin. No. We're looking at the properties. So we'll just look at what it is. What does soft water do? Soft water, okay, let me just do something like this for you to understanding. So for soft water, number 1, it easily forms leather with soap. That is, you see that when you are using soft water, is with soap, it easily becomes soapy, foamy. Understand? Foamy. Of course, when looking at water, it looks the same. But how do you know that one is soft and one is hard? The soft one forms leather with soap, and the hard one does not form leather with soap easily. So you see, you just keep on washing, wasting your soap. Wasting your soap. Before it becomes soapy, you will have to apply much soap for hard water to form leather, to form soapy, to become soapy. But this one does not do that. Okay, salt water contains few or no dissolved salts of calcium or magnesium. Okay, I can put that one down. It contains, sometimes I find it difficult to spell this word. Contains few or no dissolved, dissolved salts of calcium or magnesium. Okay, but this one contains dissolved, that's hard water, contains dissolved salts of calcium ion or magnesium ion. Yep. Okay. Salts. Okay. So the third one, I say example of salt water. So example. So you ask yourself, where can I see salt water so I don't waste my soap? Well, if you want salt water, you go to look for rainwater. Rainwater. Look at distilled water. Distilled water is used in a lab because it's pure. Then okay, so hard water is the one that has salt already. Yeah, salt, like seawater is hard water. Seawater is hard water. So another thing I like to add here under hard water is that it forms scum with soap instead of leather. So, okay, yes. So I can say it forms scum with soap. Scum with soap instead of leather. Leather is not animal skin, but it's just like foam. That's soapy nature. So the types of hardness, you know, this hard water has two types. We have temporal hardness, and permanent hardness. Temporal hardness and permanent hardness. So these are the two types of hard water. Salt water does not have types. Doesn't have types. So temporal hardness, okay, So how do we get temporal hardness? Okay, let me just break it down. I've intended to just say it, but let me just put it down on the board. So on the board I have the types of hardness. So temporal hardness and permanent hardness. So temporal hardness is caused by dissolved calcium hydrogen carbonate. This is the compound. While permanent hardness is caused by calcium or magnesium sulfides or chlorides. So you see the changer here. The changer here is the sulfides of calcium or magnesium or chloride. While this one is hydrogen carbonate of calcium. Oh yeah. So it can remove temporal hardness by boiling. So a simple boiling of water can liberate this compound from it, making it not to be hard again. But this one, there's no solution for this one. You cannot boil it. Can't boil it. If you boil it, it will still be hard. Okay, so that's just it. But you remove temporal hardness by boiling water, by boiling it, and by the time you do it, you decompose this guy. When you boil this guy, you decompose it into this is a precipitate, and this is a gas to come out. Then the water will remain. Understand? So this one will become precipitate, can be filtered out. This one is a gas to come out, while this one will remain. Okay, so permanent hardness can be removed by adding washing soda. Oh, okay. You can, yes. What I said, just remember I said that it cannot be removed permanently. What I mean to say is that when you boil it, this one, boiling will not solve the problem. What will solve the problem of permanent hardness is by adding washing soda. And washing soda here, we mean sodium carbonate. Sodium carbonate is washing soda. So you add it, sodium carbonate, you add it to the permanent hardness water or permanently hard water. Sodium carbonate looks like this. Sodium carbonate. Okay. So when you do that, it forms insoluble calcium carbonate. So the product is insoluble calcium carbonate or magnesium carbonate. Insoluble means that it does not dissolve. So that when this one comes out as precipitate, you can filter it out. You can filter it out. So okay, what does that mean to say? So ion exchange resins replace calcium and magnesium ion with sodium. Distillation, pure water is obtained on condensation. Use of lime for both temporal and some permanent hardness. So the process of removing hardness in water, you need to do some for this case you boil, then this precipitate will be filtered out. For this case, you put for reaction. When you do the reaction, this and this will come out. They will come out, and you can now distill them. Pure water can be gotten by distillation. Distillation means that when you boil the water, some parts will come out. Some water, which is a component of the whole mixture, will boil at a particular degree and to come out. Okay, so how do we treat water? Okay, so water treatments makes water safe for drinking. You know, because water is very, very soluble, it can easily mix with anything. Understand? So that's hence we have water treatment, and if you do water treatment, it makes it safe for drinking and domestic use. So what are the stages of water purification? Number one, screening, removal of large particles. So you screen to remove large particles. Screening basically has to do with filtration. Understand? Sedimentation, settling of suspended solid. Then you have coagulation, addition of alum to clump particles. This is another process, the third one. The fourth one is filtration, removal of fine particles using sand filters. Then the fifth one is chlorination, addition of chlorine to kill microorganisms, then pH adjustment, ensure neutral or slightly alkaline pH. So you know those guys that do pure water in Nigerian climate, we do pure water factory and everything. They have to go through all this process to purify water for us to drink. Those companies that also package water, clean water, drinking water, you see that they go through these 6 processes. I'll mention them again. Number 1, you have screening. They screen the water, that they remove large particles from the water. Then 2, they do sedimentation, settling of this suspended solid. So it sediments. There's a process called sedimentation. The 3rd one is coagulation. You add alum to clump particles. The 4th one is filtration, removal of fine particles using sand filters. The 5th one is chlorination, addition of chlorine to kill microorganisms. And lastly, pH adjustment. That's the 6th one. Ensure neutral or slightly alkaline pH. So, so for industrial or laboratory use, further purification may include distillation or deionization. Please note these 2, distillation or deionization. All right, so water cycle. So in water cycle, you have, it's described as a natural process, process or continuous process by which water moves between the earth and the atmosphere. Okay? So water cycle is actually the process, or is a natural continuous process by which water moves between the earth and the atmosphere. So this is the earth, this is the earth, this is the earth, clouds. Let me just put one tree here, so you know that this is earth. Put another tree here. This cloud, and this sun here. Wow, beautiful sun. So this is the earth. Okay, so it's just this fancy process, continuous process or natural process by which water moves between the earth and the atmosphere. So this is the atmosphere. Okay, so the steps for water cycle is evaporation. If I have a small river here, let me just call this a river, collection of water. So if the sun hits the river, what happens? Water changes to vapor. So it changes to vapor, it goes up like this, change to vapor. That's under evaporation. The temperature increases because of the sun. So the water molecules begin to escape from the water body, and it goes through evaporation. Condensation is the process where the vapor cools to form cloud. So this thing goes up until it forms this cloud. This is a cloud, of course. Cloud. Please, Gen Z, this is not a cloud for IT. This is natural cloud. Okay. So when it forms cloud under condensation, so at this point, the vapor cools and forms clouds. So it turns from vapor to cloud. Precipitation has to do with water falling as rain. So this cloud eventually will fall as rain. Rainfall is coming down again. Probably the water is collected at this point. Let's call this point Kubwa. Collected at this point, and it goes to fall in Kuje. Why? Because the cloud moves. So this water that was collected here moves and went and so, but that's precipitation. All right. The 4th one is collection. Collection. Water gathers in the river. Okay, so when it falls, you see your channels, your canals, the roads, everything. The water just flows and goes to the river and collects at the river. Infiltration. Some water seeps into the ground. So water, the water that is falling as rain, some of them seep into the ground. This same ground that this thing came out from, it seeps inside, understand, and forms underground water. Of course, that's what they call underground water. Under the earth, underground water. That's where you get your borehole. Underground water. That's where those people that dig borehole, that's where they get their borehole from. Transpiration has to do, did I say some transpiration? Transpiration, not transportation. Water evaporates from plant into the atmosphere. Okay, again, this same water, a circle has been formed. From here, it goes like this, it comes like this. Then the plant, this plant here, it gets, of course, the plant gets its own water from the earth. This one that entered the earth. So it gets water from the earth and also gives it out through photosynthesis, through transpiration. Okay, so this cycle ensures that we have continuous water supply and supports all forms of life. Another saying that they say water is life. There's no way life can be sustained without water. The plants need this, the animals need it, human beings need this. Every living thing needs water. And this is how the cycle is for nature, to ensure that every part of nature, living nature, gets its own fair share of water. So I hope this video has been informative for you. I'd like to thank you for viewing. Please check the description for past questions and answers, and do enjoy viewing.